dear viewers, welcome to this video in which we will discuss about Introduction to NDT and Visual Testing. Myself Dr. Biniar Weston talking to you through this video. So NDT stands for non-destructive testing. As its name implies, non-destructive testing means testing of materials without destroying them. A non-destructive test is an examination of an object which will not produce any kind of damage or destruction to the sample. Non-destructive testing is a process of inspecting, testing or evaluating materials, components or assemblies for discontinuities or differences in characteristics without destroying the serviceability of the part or the system. In other words, it is an inspection or testing which is completed and the part can still be used. So, non-destructive testing is an examination which can be performed on objects of any type, size, shape or material to determine the presence or absence of discontinuities or to evaluate other material characteristics. So the other terms which are used to denote NDT are non-destructive evaluation and non-destructive inspection, which can be shortened as NDE and NDI. So the major task of NDT is to detect and identify the range of defects which may be produced due to production flaws or fatigue cracks. Uses of NDT methods. So the primary uses of NDT methods is to identify and evaluate the flaws which may be produced due to heat treatment cracks, which may be produced due to grinding or some voids are present in the material or fatigue cracks. Leakage detection can also be done using NDT methods. The dimension of the material components can be measured using NDT methods. The structural and microstructural characteristics of the materials in the components can be identified using NDT methods. The physical and mechanical properties can be estimated using NDT methods. And materials, the kind of materials used, material sorting can be done using NDT methods. The stress and strain response and dynamic response can be measured using NDT methods. The chemical compositions of the materials can be determined using NDT methods. There are various types of materials which can be broadly classified into metals, ceramics, polymers and composites. All these materials exhibit different properties and qualities. The properties of materials provide basis for predicting its behavior under various conditions. So, metals, mainly copper, lead, tin, nickel, steel and zinc are metals. And polymers like Teflon, rubber, plastics, polyesters, sugarcane, DNA, RNA, wool, they are categorized under polymers. Materials like earthenware, stoneware and porcelain are categorized as ceramics. The combination of one or more different materials bring up composites. An engineer must have wide knowledge of materials and their properties so that he can select suitable material for this product. So material properties can be categorized as physical properties, which include color, density, melting point, size, shape, surface, finishing, damping capacity, specific gravity, porosity and structure. Then we have chemical properties which include corrosion resistance, atomic weight, equivalent weight, valency, molecular weight, acidity, alkalinity, atomic number, chemical composition, etc. Then we have mechanical properties, which include strength, elasticity, plasticity, ductility, brittleness, hardness, toughness, stiffness, resilience, etc. Then we have electrical properties, which involve resistivity, conductivity, capacitance, dielectric constant, dielectric strength, etc. Then we have magnetic properties, which include relative permeability, relativity, retentivity, susceptibility, hysteresis, then coercive force, etc. Then we have thermal properties, which include specific heat, thermal capacity, thermal conductivity, thermal stress, thermal fatigue, thermal shocks, latent heat, etc. Then we have technological properties, which include malleability, machinability, castability, etc. Then we have aesthetic properties, which include appearance, texture, then ability to accept special finishing, etc. Then we have economic properties. Economic properties include raw material and processing cost, availability. Then other properties of materials are like optical properties, acoustic properties, and physico-chemical properties. Material testing is used to evaluate the various properties of materials, to evaluate and detect the surface and subsurface defects in the processed parts or in the raw materials. The chemical compositions can be tested using material testing. The suitability of a material for a particular application can be determined using material testing. We can predict the strength and serviceability of a material using material testing. Material testing can be broadly classified into two types, namely destructive testing and non-destructive testing. First, destructive testing. In this type of testing, the component or specimen to be tested is destroyed and cannot be reused. After being destructively tested, the component or specimen either breaks or remains no longer useful for future use. As the name suggests, destructive testing includes methods where the components or specimen is broken down to determine physical and chemical properties such as strength, toughness, and ductility. Destructive testing is generally more suitable and economical for mass-produced objects, as the cost of destroying a small number of pieces is negligible. It is usually not economical to do destructive testing where only one or very few items are being produced. Destructive testing includes mechanical testing, macro test and micro testing, as well as material analysis and metallographic examinations. Some of the destructive testing methods include tensile testing, compression testing, bend testing, impact testing, fatigue testing, hardness testing, corrosion testing, creep testing, etc. The benefits of doing destructive testing are verification of properties of a material, determination of quality of weld, reduce the failures, accidents and cost, ensure compliance with regulations. Then we have non-destructive testing. In this type of testing, the component or specimen to be tested is not destroyed and can be reused after the test. As its name implies, non-destructive testing means testing of components or specimens without destroying them. As defined already, non-destructive testing is a process of inspecting, testing or evaluating materials, components subassemblies for discontinuities or differences in characteristics without destroying the serviceability of the part or system. The non-destructive testing can be done in manufacturing level or during fabrication level, or in service inspection can be done. Non-destructive testing can be performed on components during manufacturing, after manufacturing, and while in service. NDT methods can be broadly classified into the following methods, which are visual inspection, magnetic particle inspection, dye penetration inspection, ultrasonic inspection, film evaluation of radiographic images. Then we have eddy current testing, thermography, laser testing, leak testing, acoustic emission testing, etc. The objectives of NDT are the following: material sorting, material characterization, property monitoring, thickness measurement, defect detection and location, and defect characterization. The significant features of NDT includes: NDT can be performed in an object of any size, shape, type or material. The entire production can be inspected, or a selected sample can be inspected. Also, different tests can be applied on the same material either simultaneously or sequentially, and the same test can be repeated on the same specimen for additional verification. It may be added that NDT equipment is often portable. This permits the use of NDT methods for on-site testing in most locations. Because NDT does not permanently alter the specimen being inspected, it is high valuable technique that can save both time and money in production evaluation, troubleshooting and research. Non-destructive testing make components more reliable, safe and economical. The basic components, the four basic elements of any non-destructive testing are as follows. First is source or probing medium. Then we have a detector, then we have a recorder, then we do interpretation. First, source or probing medium. Source or probing medium can be used to inspect the specimen under test. The source of probing medium can be a liquid penetrant, magnetic particle or ultrasonic wave or radiation. This probing medium must be changed or modified, because of which the discontinuities with the specimen can be studied. Then the detector, a sensitive detector or sensor which can detect the change in the probing medium is the detector. Then we have the recorder. A recorder or an indicator is used to indicate or record the responses from the detector. Then we have interpretation. Various means of interpreting the recorded results through peaks, graphs, bar diagrams, etc. is interpretation. So these are the basic elements of non-destructive testing. So when we compare destructive testing and non-destructive testing, by definition, destructive testing, the components or specimen to be tested is destroyed and cannot be reused after the test. In non-destructive testing, the component or specimen to be tested is not destroyed and can be reused after the test. Examples of destructive testing include tensile test, compression test, shear test, harness test, impact test, fatigue test, creep test, bending test, torsion test, and chemical analysis. Whereas non-NDT testing methods include visual inspection, liquid penetrant testing, magnetic particle testing, thermography, eddy current testing, ultrasonic testing, acoustic emission testing, radiographic testing, leak testing, and laser testing, etc. Based on the suitability, destructive testing is generally performed when the component or specimen can no longer be used in service or is readily replaceable, while NDT can be performed on components or specimens which is in service. On the basis of advantages, destructive testing have advantages like they provide direct and reliable measurements. They provide quantitative measurements. Result interpretation is easy. It can be performed without very high skilled personnel. The correlation between test measurements and material properties is direct. Whereas in case of non-destructive testing, tests are done directly on the object and 100% testing on actual components can be performed. Different entity methods can be applied on the same specimen and hence many or all properties of interest can be examined. And non-destructive test can be repeated on the same specimen and it can be performed on components which are in service. Little or no specimen preparation is required. The test equipment is often portable. Labor costs are usually low. Most NDT methods are quick. Based on limitations, destructive testing are performed only on samples and components may not be representative of the group. Test parts are destroyed during test, usually cannot repeat a test on the same specimen. Usually cannot use the same specimen for multiple destructive testing. May be restricted by costly or few in number parts. Difficult to interpret cumulative effect of service usage. Whereas in case of non-destructive testing, measurement is indirect, reliability is to be verified, measurements are often qualitative or comparative. Result interpretation is often difficult. Skilled personnel are required for testing and result interpretation. Different observers may interpret the test results differently. Some test equipments require a large capital investment. NDT methods can be further classified into direct methods and indirect methods. Direct methods involve direct interaction with the material to assess its integrity and condition. Direct methods typically provide immediate visual or measurable results. Methods like visual inspection, liquid penetrant testing, magnetic particle testing, ultrasonic testing are direct methods, whereas in indirect methods they do not require direct contact with material or rely on secondary measurements to infer the condition of the material. These methods often involve the use of sensors or equipment that analyze responses from the material. Methods such as radiographic testing, eddy current testing, acoustic emission testing, and thermography are indirect NDT methods. Before selecting a suitable NDT methods, some parameters or factors have to be considered. They are the type of discontinuity, the origin of discontinuity, the material manufacturing process, the accessibility of component, types of equipment available, time availability and cost. So then we come to visual inspection. Visual inspection is the simplest, fastest and most widely used non-destructive testing method. It is carried out with the naked eye, which is unaided, or using some optical aids like mirrors, magnifying glasses, microscopes. Then it is called aided. Visual inspection is commonly defined as the examination of a material, component or product for conditions of non-conformance using light and eyes alone or in conjunction with various aids. Visual inspection often also involves shaking, listening, feeling and sometimes smelling the component being inspected. Visual inspection is commonly employed to support or complement other NDT methods. Digital detectors and computer technology may have made it possible to automate some visual inspection. This is called machine vision inspection. The visual inspection is commonly used to detect surface characteristics such as finish, scratch, cracks or color. The principle of visual inspection is seeing believes, and the art of seeing is the visual inspection technique. Visual testing requires adequate illumination of the test surface and proper eyesight of the tester. The test component is illuminated and the surface of the test is observed and examined. Wherever required, optical aids such as mirrors, magnifying glasses, microscopes, video cameras and computer vision systems can be employed. The advantages of visual inspection include they are simple and easy to use, relatively inexpensive, testing speed is very high, testing can be performed on components in service, permanent records are available when the latest equipment is used. The limitations of visual inspection include the test results depend on the skill and knowledge of the tester. It is limited to detect surface flaws. Eye resolution is weak. Eye fatigue are some limitations of visual inspection. The applications of visual inspection include checking of the surface condition of the component, checking of alignment of muting surfaces, checking of shape of the component, checking for evidence of leaking, checking for internal side defects. With this, we come to the end of this video. Thank you for patience and listening.